So after our job is complete, we want to check if it has been terminated normally or if there are any anomalies in the file. So that would indicate that there is either something wrong with the geometry or with the input file itself. So what we do is we first look at the log file. So that would be benzene.log in this case. So we go to the very end of the file to look for the line that says that execution of games is terminated normally, which would mean that all the calculations that was required in the MAKEFP job run for this file has been completed without any kind of abnormalities. So what we can do is we can directly go to the .efp file now and have a look at it. So we now go to have a look at our .efp file. So we see that everything, all the data or all the parameters that we need for our EFP calculation has been generated in the .efp file. So if we move down the file, we see that we first have the coordinates of the atoms in our fragment, along with the coordinates of the bond midpoints. We also have the monopoles, the dipoles, quadrupoles, and the octupoles, which are basically what we need to calculate our electrostatic interaction energy, which is calculated in form of distributed multipole analysis along the atom centers and bond midpoints. We have the polarizable points, which are basically needed for our polarization interaction calculation. We have our dynamic polarizable points, which contain the coordinates and values of the anisotropic dynamic polarizability tensors, which we need for the dispersion energy calculation. So the next section is the projection basis set, which is basically needed for our exchange repulsion calculation, our overlap-based electrostatic and dispersion energy dampings. So then we have the multiplicity of our fragment, which is 1 in this case. Then the projection wave function, which is basically required, which is the localized wave function of the fragment, which is required to compute the exchange repulsion and the overlap-based electrostatic and dispersion energy dampings again. So the next section is the Fock matrix elements, which basically contains the Fock matrix elements of the fragment in the localized spaces. This is again used for the exchange repulsion calculation and the dispersion overlap-based electrostatic and dispersion energy dampings. And the LMO centroids basically contain the coordinates of the localized molecular orbital centroids. And finally, we have the screen and screen 2 parameters, which are basically the screening parameters that we require for the account for the QM EFP interaction and the EFP EFP interactions in an EFP calculation. So screen 2 is generally used for the calculation of interaction energy between two AFP fragments, and screen is basically used for calculation of the screening parameters between the QM EFP fragments.